solid state.
A compound contains two types of atoms X and Y. It crystallizes in a cubic lattice with atoms X at the corners of the unit cell and atoms Y at the body center. The simplest possible formula of this compound is answer option C, XY. So we can see the solution of this question. X atom at the corners. If an atom at the corner, its contribution is 1 by 8. So total number of atom X is equal to 1 by 8 into 8 corners are there for a cube. Therefore 1 by 8 into 8 is equal to 1. And Y at the body center. If an atom at the body center, its contribution is equal to 1 because atom at the body center not shared by any other unit cell. Therefore Y equal to 1. X1, Y1. Formula is XY. Question number 2. If Z is the number of atoms in a unit cell that represents the closest packing sequence ABC ABC, the number of tetrahedral voids in the unit cell is answer option B, 2Z. We can see how the answer is given. If closest packing sequence ABC ABC means CCP. So if a crystal have HCP or CCP structure and its total number of atoms in a crystal is Z,
Octahedral void is equal to Z.
and number of tetrahedral void is equal to 2Z. Our question is how many number of tetrahedral voids are there? Answer is 2Z. Option B is the answer. Third question. Which of the following crystal does not exhibit Frenkel defect? Which of the following crystal does not exhibit Frenkel defect? Answer is option C, KBr. So look at the answer. If a crystal shows Frenkel defect, that may be mainly due to dislocation of cations to the interstitial position. An example should be silver and zinc compounds. So here AgBr, AgCl, ZnS, silver and zinc compounds, they shows Frenkel defect. But KBr, it is an alkali metal halide. Alkali metal halides generally shows Schottky defect. Schottky defect examples alkali metal halides and AgBr. Schottky defect generally occur due to the missing of equal number of cations and anions.
AgBr shows both.
Next question. What is the coordination number of sodium in Na2? Coordination number of sodium in Na2. Answer is option A, 4. So look at the answer. Coordination number of sodium in Na2. Na2 has anti-fluoride structure. And its coordination number is 4:8. That means 4 for sodium and 8 for oxygen. Crystal lattice is calcium fluoride CaF2. CaF2 coordination number 8:4. Calcium 8, fluorine 4. ZnS, zinc 4 and sulfur 4 is the coordination number. And sodium chloride, coordination number of sodium 6 and chlorine 6, that is 6:6. Cesium chloride, coordination number of cesium 8 and Cl 8, that is coordination number 8:8. Next question. A metallic crystal has BCC type stacking pattern. What percentage of volume of this lattice is empty space? A metallic crystal has BCC type stacking pattern. What is the percentage of volume of this lattice is empty space? Answer is option B, 32. Check the answer. For BCC, packing efficiency 68%. 68% space is filled, therefore empty space is 32%. So answer is 32. For FCC, packing efficiency 74%, therefore volume of empty space 26%. For primitive cubic unit cell, packing efficiency 52.4%, therefore volume of empty space is 47.6%. Question number 6. AB crystallizes in a body-centered cubic lattice with a edge length A equal to 387 picometer. Distance between two oppositely charged ions in the lattice is. AB crystallizes in a body-centered cubic lattice BCC and distance between two oppositely charged ions. We can check the answer. So for BCC structure, for example, cesium chloride, cesium ion, cation at the body center and anion at the corner. Usually different oppositely charged ions are present at the corners and body center. So here one atom is at the corner and oppositely charged ion, that may be cation, at the body center. We want to see the distance between these two oppositely charged ions. Draw a body diagonal like this. If the edge length of the cube is a, then body diagonal is root 3a. We want to measure the exact half of this body diagonal, that is root 3a by 2. Therefore, distance between two oppositely charged spheres, closely packed oppositely charged spheres, is root 3a by 2. Therefore, root 3 into a is 387 picometer, root 3a by 2. Answer is 335 picometer. That is answer. Option D is the answer. Next question. If NaCl doped with 10 raised to minus 4 mole percentage of strontium chloride, the concentration of cation vacancy will be? Check the answer. Take an NaCl crystal. This NaCl doped with a strontium chloride. SrCl2 is the impurity. While adding impurity, a defect is created that is called the impurity defect. So if one Sr2 plus enter into the crystal, to maintain electrical neutrality, 2 Na plus is lost. Therefore 2 place is vacant. But one Sr2 plus enter into this crystal, that is. So while adding one Sr2 plus, one cation vacancy is created. Therefore, number of impurity and number of cation vacancy is same for impurity defect. Therefore, we want to calculate total number of cation vacancy, that is equal to number of impurity. 1 into 10 raised to minus 4 mole percentage of strontium chloride. 1 into 10 raised to minus 4 percentage, that's divided by 100. Therefore, 1 into 10 raised to minus 6 into Na. By simplifying, we will get 6.023 into 10 raised to 17 mole per mole. Next one. Total volume of atoms present in a face-centered cubic unit cell of a metal is? That is the atomic radius of metal. Check the answer. So here face-centered cubic unit cell. In FCC unit cell, number of atoms is 4. Number of atoms means number of sphere is 4. And volume of one sphere is 4 by 3 pi r cube. Therefore, volume of the unit cell is 4 into 4 by 3 pi r cube, that is 16 by 3 pi r cube. Answer is 16 by 3 pi r cube, that is option D, 16 by 3 pi r cube. If the crystal is BCC, number of atom is 2. Therefore, volume of the unit cell 2 into 4 by 3 pi r cube, 8 by 3 pi r cube. If it is primitive cubic unit cell, number of atom is 1. Volume of the unit cell 1 into 4 by 3 pi r cube, that is same 4 by 3 pi r cube. Next question. Arrangement of X minus ions around A plus ions in solid AX is given in the figure. If the radius of X minus ion is 250 picometer, then the radius of A plus ion is? So here we can see total 6 X minus ions are there and A plus ion is present at the voids. If A plus is surrounded by 6 X minus ion, that creates an octahedral void. So A plus ions is present at the octahedral void. If a cation A plus is occupied at the octahedral void, there is a relationship there. Radius of cation is equal to 0.414 into radius of anion. So your radius of cation, that is radius of A plus, equal to radius of A plus is equal to 0.414 into radius of anion is 250 picometer, and our answer is 104 picometer, option A. So generally in crystal HCP and CCP, two types of voids are there, octahedral and tetrahedral void. For octahedral void, radius of cation and radius of anion relationship is 0.414 into radius of anion. For tetrahedral void, radius of cation equal to 0.225 into radius of anion. So remember these two equations. Iron exhibit BCC structure at room temperature. Above 900 degrees Celsius it transforms to FCC structure. The ratio of density of iron at room temperature to that at 900 degrees Celsius is. Check the question. Iron exhibit BCC structure at room temperature. Above 900 degree transform to FCC. Ratio of density of iron at room temperature to that at 900. So assuming molar mass of an atomic mass of ions are constant. So we can check the answer. We want to calculate the ratio of density. Equation for density, rho is equal to Zm divided by A cube Na. Z, number of atoms, M molar mass, A edge length, and A Avogadro number. For BCC, Z is equal to 2 and I is equal to 4 by root 3r. And for FCC, Z is equal to 4. A is equal to 2 root 2r. So density for BCC, that is at room temperature, rho 1 equal to Z1 M divided by A1 cube Na. And for density for FCC, rho 2 is equal to Z2 M divided by A2 cube Na. By taking the ratio of these two, 1 and 2, rho 1 by rho 2, M and Na, molar mass and Avogadro number, their constant is cancelled.
Therefore, rho 1 by rho 2 is equal to Z1 by A1 cube into A2 cube divided by Z2. Substitute the value of Z1 and A1. Z1 is 2 and A1 4 by root 3r. A2 cube, A2 2 root 2r whole cube, and Z2 4. By solving, we will get the answer 3 root 3 divided by 4 root 2. So answer is 3 root 3 by 4 root 2. Therefore answer is option B.